Remember, guys, this is a GDC paper, okay? So question 9, 14 marks. You've got about 15 to 20 minutes to do it. Let's see what we can do. Type in the function. 2 times by, go for your little trig button. Sine, open up the brackets. You can put a little fraction in here. Change it to x, remember? X over 10 to the right, plus, get a little fraction again. So do exactly what it says on the question. Scroll right, times trig cosec. Brackets there, ready? Same again, fraction button. X 30 plus pi divided by, let's see if it'll do it nicely. Yeah, I think that'll be okay. Okay, let's try that. All right, does that look right? Well, now look at the scale. So go menu, window settings. We are 0 to 60. Y min, what, -3 maybe? Y max, +3. See what that looks like. Okay, so look, it looks just like the picture on screen there. So we are clearly in radians, so that's great. Let's have a look then. A1, determine the coordinates of point A and the coordinates of point B. Menu, analyze graph. Maximum. There we go. Menu, analyze graph. Minimum. Press escape. Grab the points, move them around a bit. Notice mine around to 3 sig fig. That's absolutely great. If you weren't, menu, settings, float 3, change, float 6, okay. And you get more accuracy with your coordinate points, all right? So that might be a top tip. If you're on float 2, then that's not such a good thing. Float 3 is okay. Maybe just go wider with a wider float, bigger float, and you can round off by yourself. Now just think about what the actual values mean. This is time, 7.47 seconds, velocity 2.28, time 43.37 seconds, velocity -2.45. So that's just speed in the opposite direction. This is the greatest speed. Maximum velocity, minimum velocity, but this 2.45, because speed has no magnitude, is the greatest speed. So we've already done A part 1, A part 2. We've already picked up loads of marks, all right? I'm going to keep going with it. The body first comes to rest at time t equals t of 1. Rest, velocity is 0. Menu, analyze graph. Zeros. First comes to rest. This particular time. 3 sig fig, 25.1. The distance travelled between t equals 0 and t equals t of 1. Area bound by the velocity time graph. But remember, it's the positive area that we want. Menu, analyze graph. Integral between, type in 0, enter, point to the intersection point. Distance travelled, 25.1 meters, because I think this is velocity meters per second. Meters per second, yeah, 25.1 meters. Next one, the acceleration when t equals t of 1. Acceleration equals rate of change in velocity. Menu, analyze graph. dy by dx of this graph at which point? At this point. dy by dx is, grab the number, -2.00. Acceleration is negative because we are going from a positive velocity to a negative velocity, therefore we are decelerating. Have we now finished? Oh, we have. Find the distance travelled in the first 30 seconds. 25 seconds here. We have travelled the old 41 meters. Then we start travelling back to where we started. 30 seconds is up here. So there's one cheeky little thing we can do. Go back to here. And now F1 equals absolute value of our function. This will allow us to bounce back now when we plot it. And now menu, analyze graph, integral from 0 up to 30. And we have our final number, which is here. Press escape, grab the number, and the total distance travelled, can I grab it? I think I can, is 43.3 meters. So with a little bit of writing down, yeah, just maybe actually writing down a method rather than just writing all those answers, that won't take you too long. I'm going to stop the video now and then